So we're looking at solving quadratic equations. So we looked at last week solving linear equations. When we started a linear equation, it might not have been in the form of a linear equation, but as we went through the process of solving the equation, we got a linear equation. For today, we're going to look at solving quadratic equations. There's different methods of solving quadratic equations. So one of the methods we can solve by factoring, if it's factorable. We can solve quadratic equations by using a square root method. I'll go through the process of proving the formula or how we got the formula of the quadratic formula by using the completing the square method. So completing the square method is another method that we use, which is something that we're going to be using throughout the class. So we'll see completing the square method later on in this course. And then we'll look at some problems that can be modeled by using quadratic equations. So let me start with the standard form of a quadratic equation. So a standard form of a quadratic equation is when it's set equal to 0. So the standard form is ax squared plus bx plus c is equal to 0, where we say that a, b, and c are real numbers. So remember that capital R with the two vertical lines represents the real number system. So a lot of times when we're solving quadratic equations, we want to get it into this form. So we want to get everything to one side of our equation. And then if possible, we want to factor it. If it's factorable and it's set equal to 0, then we can use the 0 property, where that says if you have two things multiplied together and you get back 0, then at least one of them has to be 0. So for instance, if you had a times b, not the a and b above, but if you had a times b is equal to 0, then either a equals 0 or b is equal to 0. So when we're solving using factoring, this is the property that we're using. So let me pull some examples and let's just go through. Hopefully you remember how to factor. If you don't remember how to factor, that's something that you're going to need to review up on. Okay, so we have our first set of problems in front of us. So it tells us that we want to solve the quadratic formula, or sorry, quadratic equation by factoring. So the first example is x squared plus 2x minus 15 equals 0. So it's in the form, standard form, where everything is to one side of the equation. And so now we want to factor this. When I factor, I kind of look at how many terms I have. I have 3 terms. So that tells me, and it's in the form of x squared plus 2x minus 15. The coefficient in front of the x squared is 1. So what we're trying to do is we're trying to find two numbers that multiply to give us our constant. I tend to kind of write it like this, but I know you guys write it a little differently, so I might change it up. So I'm trying to multiply, that x means multiply, to give me negative 15, and add to give me a positive 2. So you might have seen it before with an x here, negative 15 adds to 2. So thinking of two numbers that multiply to negative 15 and add to 2. Well, if I multiply and I get a negative number, I know one is positive, one is negative. So I would ignore my negatives for a second. I know 5 times 3 is 15, and 5 minus 3 is 2. So if I use a positive 5 and a negative 3, those are the two numbers that satisfy both of those conditions. So when we factor, here we have x plus 5, and we have x minus 3 is equal to 0. So now we can just set each factor equal to 0 and solve. In this case, these are linear factors. So we're looking at when is x plus 5 equal to 0 and when is x minus 3 equal to 0. So isolate your variable x for each one of those equations. We get x is equal to -5 by subtracting 5 on both sides, and x is equal to 3 by adding 3 to both sides. And so our solutions are x equals -5 and x equals 3. So same process for part B. We have x squared minus 8x plus 16. So we're looking for two numbers that multiply to give us our constant, which is positive 16, but would add to give us -8. So looking at what multiplies to get 16 and adds to -8. So if you feel more comfortable writing it like this, you can. What multiplies to 16? Well, I noticed that it's multiplying to give me a positive number, and I'm adding those two numbers and I get a negative. So I know when I choose these two numbers, they both have to be negative. So two numbers that multiply to give me 16 is 4 times 4. But they both have to be negative. So -4 times -4 is -16. I'm sorry, it's positive 16, but if we sum it, it's -8. And so we can rewrite this as x minus 4 all times x minus 4 is equal to 0. Okay, so we just factored the left-hand side. And so now we're looking at x minus 4 equal to 0 and x minus 4 equal to 0. And we're going to get the same result in each case. We would add 4 to both sides. So we get x is equal to 4. We have one solution, 4. And so we're going to see later on in the semester that notice that x equals 4. That occurred twice. So we would say that that has multiplicity 2. The multiplicity is going to actually tell us what's going on when we are looking at the graph of the function x squared, in this case, x squared minus 8x plus 16. Is it going to cross the x-axis or is it going to touch the x-axis at these x values? And so we'll look at that later on in the semester. But if it's an even multiplicity, this is multiplicity 2, it just touches the x-axis. And if you had an odd multiplicity, it would cross the x-axis when we're looking at graphs. So you don't have to worry about that little piece right now. Hopefully that's a reminder from a previous course, but we'll get into that in more detail when we get to that section. So let me pull another problem for you. So we have our next two problems in front of us. We have x squared minus 5x equals 0. Again, it told us we wanted to solve this by factoring. Notice that there's two terms. So normally how I approach factoring with two terms is a little different than three terms. When we're looking at factoring, though, we always should see if there's anything that we can pull out of all of the terms that are in there. And the other two cases that we looked at, there wasn't anything. But looking at problem C, I have x squared minus 5x. So x squared and -5x both have an x in common. So we can factor out that variable x. So if we pull out one x from x squared, you'll be left with a single x. And if we pull out an x from -5x, we're just left with -5. So we're going to do -5 here is equal to 0. Once you pull out the greatest common factor, you would see, does it factor any further? And it doesn't. So setting each factor equal to 0, we have x is equal to 0 and we have x minus 5 is equal to 0. So adding 5 to both sides, we get x is equal to 5. So x equals 0 only occurred once, and x equals 5 only occurred once. We would say that that had multiplicity 1 if it would ask for multiplicity. Okay, so we have two solutions in here. Your book might ask you, or your homework program might ask you to put this in set builder notation. So let's just review that really quickly. So set builder notation, we use what I call these curly brackets. So we have this set. Look at the variable that you're looking at. In this case, it's x. So we would put that x there. So it's a set of x. This vertical line means such that. So it's x such that, and then after that vertical line, you put your stipulation. Well, our stipulation is that x has to either equal 0 or x is equal to 5. And then end the curly bracket. So again, this is called set builder notation. And the way that it reads is it's a set of x such that x is equal to 0 or x is equal to 5. So looking at the next problem, we have 2x squared minus 5x equals 3. So notice that this is not in standard form. It's not set equal to 0. So we want to rewrite this so that it is set equal to 0. So I think the easiest thing to do in this case to get it set equal to 0 is let's get rid of the 3 on the right-hand side, and we can do that by subtracting 3 on both sides of our equal sign. So we have 2x squared minus 5x minus 3 is equal to 0. This is a harder case because that coefficient, that number in front of the x squared is not 1. And so there's multiple different ways that you can do this. You can use trial and error to try to do this, or we can use what is called the AC method. So recall, standard form was in the form of, we wrote it as ax squared plus bx plus c. When we're using what I call the AC method, we're looking at what multiplies to give us AC and what would add to give me that middle coefficient, the number in front of x, which in our case is b. So for our example, our A coefficient, the number in front of the x squared, is 2. And our constant, the number without the x, is -3. Use the sign with it. And so if I multiply 2 times -3, I get -6. My middle term, my B coefficient, is -5. So you're looking for two numbers that multiply to give me AC, which is -6, and that would add to give me -5. So I know I'm multiplying and I'm getting a negative. So one has to be positive, one has to be negative. I notice when I sum those two numbers that I get a negative answer. So my larger one has to be bigger. And so I see in the chat, and you're right, the two numbers that you would use to get that would be -6 and +1. So if we multiply to get -6 times 1 is -6, and -6 plus 1 gives us -5. This is a little different, though, than what we had done before. We can't just go in and actually start factoring. What we want to do with using this method is we want to look at the two numbers we just found, -6 and 1, and we want to rewrite that middle term using those two coefficients. So I'm going to rewrite the middle term, but I'm going to rewrite everything. So I'm going to take 2x squared. I'm going to bring it down because I haven't done anything with it. And I'm going to rewrite the middle term as negative 6x plus 1x, but I don't need the 1 in front of the x. It's just known to be 1. So if you added, because those are like terms, negative 6x plus x, you get back that middle term, negative 5x. So it's equivalent to what we had before. And then minus 3. This is equal to 0. So once you've used the AC method, you figured out what those two values were, and you rewrote the middle term, this is where you would go and factor by grouping. So when I have 4 terms and I know how I have to factor, a lot of times factoring by grouping is what I would try. So what you're doing is you're grouping, and you might have to rewrite the order, but I'm not going to. I don't need to. You are going to group the first 2 terms and the last 2 terms together, and then you're going to factor out what is in common for the first 2 terms. So looking at 2x squared minus 6x, well, looking at my coefficient of 2 and 6, they both have 2 in common. So I'm going to pull out a 2 from both of those terms. And if I pull out a 2, I also want to pull out the variable x, because I have a single x in common. So if I pull a 2x out of that first term, 2x squared, you're left with a single x. I don't know why I did curly. You're left with a single x. And then pulling out a 2x from negative 6x, we're left with a negative 3. Notice the last 2 terms, x minus 3, they don't have anything in common. Our goal is to get what's inside the parentheses the same. And so think of it as you're pulling out a positive 1. I'm going to write that 1 there. I normally don't, but I think it helps you, or it might help you see it as we go further. So if you did this correctly, and it works, then you should find the value of the x minus 3. That factor is the same. So you want to pull that out of each grouping. So you're pulling the x minus 3 out of the first grouping, and you're pulling the x minus 3 out of the second grouping. So pulling out the x minus 3 in each piece. So pulling out x minus 3 here, I'm left with a 2x. Where if I pulled out an x minus 3 on the second grouping, you're left with a positive 1. And this is equal to 0. Okay, so looking at this, we factored it. And now we're going to set each factor equal to 0 and solve. So I'm looking at when is x minus 3 equals 0? And when is 2x plus 1? Excuse me, equals 0. Okay, so isolating your variable x. For the first equation, you would add 3 to both sides, and we get x equals 3. For the second equation, we want to isolate our variable x. You would subtract 1 on both sides of the equation, so we would get 2x equals negative 1. We need to get rid of the coefficient in front of the x, so we're going to divide both sides by 2. So we get x is equal to negative 1/2. So we factored it and found the solutions to that quadratic equation. So before we jump into using the square root method, I wanted to look at one other case. So here we have equation 5 over x plus 4. This is equal to 4 plus 3 over x minus 2. So looking at this is actually a rational equation, but when we go through and solve this, it's going to end up being a quadratic equation. When we have a rational equation where we have variables in the denominator, we have to be careful and we have to find values where what x cannot be. And those are values which set our denominator equal to 0. And so looking at this, I know that x plus 4 cannot equal 0. So if I solve for x here, I know that x cannot be -4. Not equal. And then I have another denominator of x minus 2. So I know x minus 2 cannot equal 0. And if I solve for x there by adding 2 to both sides, I know x cannot be 2. So if I go through here and I solve this and I find that one of my solutions is one of those numbers, or both of my solutions are both of those numbers, then I have to exclude them from the solution set. So recall when you are looking at this and we want to solve and we have fractions, we can clear the fractions by finding the least common denominator. And so our least common denominator, well, x plus 4 and x minus 2 are not common. They don't have any common factors. Can't be factored any further. So the LCD, or least common denominator, is x plus 4 all times x minus 2. So recall we took that LCD and we multiply both sides of our equation by that. So if I go up here and I multiply the right-hand side and the left-hand side of my equation by my LCD, x plus 4, x minus 2. So x plus 4, x minus 2. Okay, just needed to get some room. So there's nothing to distribute on the left-hand side. So we can just cancel what we have in common. And so if I do that, I have an x plus 4 here and an x plus 4. So I'm left with my 5 from the numerator, all times the factor that did not cancel, x minus 2. And this is equal to, we need to take this whole grouping, this LCD, and distribute it. So we will have 4 times x plus 4, x minus 2, nothing canceled there. And then we want to distribute it to the second piece. So 3 all over x minus 2 times this x plus 4 times x minus 2. That helps you to put that over 1, you can. Because it's multiplication, we can cancel. So I have an x minus 2 in common and an x minus 2 in common, and they cancel out. So we want to simplify down this equation. So let's start distributing things. And so looking at this 5, we can distribute it to the x minus 2. So distributing 5 times x, I get 5x, minus 5 times 2, I get 10. This is equal to 4 times. So let's distribute out x plus 4 times x minus 2. So distributing, I get x times x is x squared. X times -2 is minus 2x. Go to the next term in the first parentheses and distribute. So 4 times x gives me plus 4x, and 4 times -2 gives me minus 8. In my parentheses, plus, I have this now 3 times x plus 4. So I have 3 times x, which is 3x, and then 3 times 4, so plus 12. Okay, so I still have a little bit more work of simplifying down. So let's rewrite to the left-hand side because we can't do anything with it. There's no like terms. So we have 5x minus 10. I'm going to want to distribute my 4. I could, if I wanted to, sum the two middle terms inside that parentheses and then distribute it. But I notice I'm going to have to simplify anyways and some like terms later. So I'm just going to distribute now. So 4 times x squared is 4x squared. 4 times negative 2x gives me minus 8x. 4 times 4x gives me plus 16x. And 4 times negative 8 gives me minus 32. And then bringing down the next couple of terms, we have plus 3x plus 12. Distributed, we can combine like terms. So let's first bring down the 5x minus 10 because we can't do anything with that. Is equal to, well, 4x squared. There's no other term with an x squared, so let's bring that down. But I noticed that negative 8x plus 16x plus 3x are all like terms, and so we can sum those. So negative 8x plus 16x is 8x, and 8x plus 3x is 11x. So this would be plus 11x here. And then we have two constants. So negative 32 plus 12. That gives us a minus 30. No, that gives us a minus 20. Okay, so we've simplified down our equation on the right. And so we want to get everything to one side. So I'm just going to subtract 5x on both sides. And I'm going to add 10 to both sides. So doing that, we get 0 is equal to 4x squared. Negative 5x plus 11x, or 11x minus 5x, that gives us plus 6x. And then negative 20 plus 10 gives us minus 10. So looking at the three terms that we have left, 2x squared plus 6x minus 10, I noticed that there's a 2 in common with all three of those terms. So I'm going to factor out a 2 from all three of those terms. And if I pull out a 2 from all three of those terms, I'm left with 2x squared plus 3x minus 5. And this is all equal to 0. So we want to factor further. I notice that 2x squared plus 3x minus 5, I might be able to factor that. And so this is where we're going to go through and we're going to kind of use that AC method to help us solve. So you're looking at, and maybe we can kind of just do side work for a second and then come back to that. So let's actually do that. So I'm going to move over the screen so I can kind of look at this on the side so it doesn't get so messy. So I have this 2x squared plus 3x minus 5. I'm just looking at how to factor this. So I'm looking at a times c. So a is the coefficient in front of the x squared, which is 2. And c is the constant, which is negative 5. So that would give me back negative 10. I'm looking for something that multiplies to negative 10, but would add to give me my middle term, 3. So multiply to negative 10, add to 3. So 5 and 2 multiply to 10. One has to be positive, one has to be negative. So it's going to be positive 5 because when we sum the two numbers, it's positive, and a negative 2. So I want to rewrite this middle term 3x using 5 and negative 2. So rewriting that middle term, so I have 2x squared. Just so that I have common factors, I'm going to write minus 2x first. It would work either way. And then plus 5x. So if I sum those two terms, I get back that middle term of plus 3x. And then I have a minus 5. So factor by grouping the first two terms together. So pulling out a 2x from those first two terms, we're left with a x minus 2. And from 5x minus 5, I can pull a 5 out of both of those terms. So pulling a 5 out of 5x, I'm left with an x. And I should not... Made a mistake. I noticed that I needed to have the same thing. And so when I pulled out that 5 from the 5x minus 5, I have x minus 1 here. Going back to that first two terms, when I pulled out a 2x from negative 2x, this should be a minus 1. So x minus 1, what's inside the parentheses is the same, which I wanted to. So if I pull it out of this first two terms, I'm left with the 2x. And if I pull it out of the last grouping, I'm left with plus 5. Okay, so that was just kind of some side work so that we could rewrite this middle piece. So don't forget to bring down that coefficient of 2 in front. And we just factored what was in that parentheses as x minus 1 and 2x plus 5. So now we're going through and we're going to set each piece equal to 0. So I'm looking at when is 2 equal to 0? Well, 2 is never equal to 0. When is x minus 1 equals 0? That's when x is equal to 1. And when is 2x plus 5 equal to 0? We got to do a little more work here. Subtract 5 on both sides. We get 2x is negative 5. And then divide both sides by 2. We get x is equal to negative 5 halves. So we just need to make sure that those solutions, 1 and negative 5 halves, did not set our denominator equal to 0 in our original equation, which it did not. And so those, as long as I didn't make any errors that I didn't catch, then that should be the solution. So the square root method says if x squared is equal to p has to be greater than 0, then x is going to equal the square root of p, or x is equal to the negative square root of p. So basically, you have x squared equals some value p. All you're doing is you're taking the square root of both sides of our equation. But we have to put the plus or minus in front of one of those radicals. I usually put it in front of the one with a constant, because when we go back to square both sides, if we squared the negative, it becomes positive. And so that's why we need to put that in there. So one error students tend to make is forgetting that plus or minus here. We'll call the square root of x squared is just x, so x is equal to plus or minus root p. Is another way to write it. If our value of p was less than 0, we would get back an imaginary number because we would have a negative underneath the square root. For this section, if we got an imaginary number, we would say no solution. In the following sections, we would give out the complex number as a solution. So let's look at the following really quickly, a couple examples. So let's say you had x squared minus 7 is equal to 0. So we can use the square root method. Because we have a perfect square, just the x squared, no other term has an x in it, we can use this method. So let's isolate the square by adding 7 to both sides of the equation. And doing so, we get x squared is equal to 7. Take the square root of both sides of our equation, putting the plus or minus in front of the 1. We got the square root of x squared is equal to plus or minus the square root of 7. So x is equal to plus or minus root 7. So okay if you leave it like that, or you can say x is equal to root 7, or x is equal to negative root 7. So let's look at one more example here. And we'll see more examples of square root method when we talk about completing the square. So one other example is, what if you had x minus 4? That x minus 4 is quantity squared, minus 9 is equal to 0. So I have a perfect square here. X minus 4, that is quantity square. That's a perfect square. There's no other term outside of that parentheses squared that has an x. So we can isolate that square by adding 9 to both sides of our equation. And so if we add 9 to both sides of our equation, we get x minus 4 quantity squared is equal to 9. Now we can take the square root of both sides. So we have the square root of x minus 4 quantity squared is equal to plus or minus the square root of 9. So the square root is going to cancel out the square, leaving us with x minus 4 is equal to square root of 9 is 3. So we're actually going to have two separate equations. X minus 4 is going to equal to 3. And we're going to get the other x minus 4 is equal to negative 3. If I took that square root and of the other side and it wasn't a perfect square, I probably wouldn't have written out the two separate equations. I probably would have just left that plus or minus. But I noticed that because it's a perfect square, taking that square root, it's a integer, and I can isolate by values of x. So first equation, x minus 4 equals 3. I can add 4 to both sides. And so doing so, we get x is equal to 3 plus 4, which is 7. And then adding 4 on both sides for x minus 4 equals negative 3. Adding the 4, we would get x is equal to 1. So we have two solutions, 7 and 1. So the next method we're looking at is going to be completing the square method. Completing the square method is another way that we can solve quadratic equations. It helps lead us to the form where we can use that square root method. Completing the square method is actually how they derive the quadratic formula. Okay, so we have a quadratic in standard form, which is ax squared plus bx plus c is equal to 0. When we complete the square, that number in front of the x squared has to be 1. Right now, I just have an arbitrary quadratic equation. And so let's go through the process of what we need to do. So first step that you need to do to complete the square is make the coefficient in front of the x squared 1. So make the coefficient. So if it's already 1, then we don't need to do this step. So then we need to make the number in front of x squared equal to 1. So since this is an arbitrary quadratic equation, we don't know if a is 1 or not. So we are going to, one way that we can make that one is we can factor a out of all those terms, or another way to do it is divide every single term on both sides of the equation by a. So let's do that. So let's divide everything through by a. So if I divide everything through by a, then ax squared, all divided by a, is x squared, plus b divided by a, x, plus c over a equals, well, 0 divided by a can't be 0, because if a was 0, it wasn't quadratic. So 0 divided by a number other than 0 is 0. So once we've made that coefficient 1, if it needed to be made 1, then the next step that's helpful in solving these equations is let's get the constant to the other side of the equation. So move the constant. So that's the number without the x to the other side of the equation. So c divided by a is our constant in this case. And so what I'm going to do is I'm going to subtract c over a to both sides of my equation. And so doing so, I'm left with x squared plus b over a times x is, I'm going to leave a little bit of room in there for a second. So leave some space in here, is equal to negative c over a. So once you've isolated the terms with the variables to one side of the equation, the constant on the other, and then we're trying to make the left-hand side a perfect square in this case. And so in order to make that a perfect square, we need the same number that we would add to give us the middle term. We need to take that number and square it to give us the constant. And so to find that value again, you're going to look at half of the number we're trying to add the same thing to get. So half of, or divide by 2, but because this is a fraction, I don't want to do that. So dividing by 2 is the same thing as multiplying by 1/2. So 1/2 of b over a. We want to take that value and then we want to square it. So we're going to find that value. And we're going to add this to both sides of the equation. Add this result. To both sides of the equation. Do something to one side, we got to do it to the other. Okay, so if I square 1/2 times b over a, so I'm squaring 1 times b, which would give me b squared. I'm going to add this. All over 2a quantity squared. So 2a times 2a is 4a squared. Okay, so we have just created the one side to be a perfect square. So the same number that we would multiply to give us that constant b squared over 4a squared and would add to give us b over a, it's always going to be this value before you squared it. Which is b over 2a. So this perfect square is x plus b over 2a. Quantity squared is equal to those two fractions on the right-hand side of my equation. They don't have a common denominator, so I could get a common denominator. I noticed that for a squared and a, my least common denominator, my LCD, is equal to 4a squared. Okay, so I already have that denominator. So b squared, 4a squared. That has the common denominator, but minus c over a, I need to get 4a squared in the denominator, so I can multiply this by a fancy one. And so I need 4a more. So 4a times a gives me 4a squared. So rewriting this, I have x plus b over 2a. That quantity is squared, is equal to, I just created that I have a common denominator on the right-hand side, so I can rewrite that as a single fraction. B squared minus c times 4a is 4ac. It's another way to write it. All over 4a squared. So once you've done that, you found the number that if you sum to the one side would make the one side a perfect square, then you can use the square root method to solve. So let's take the square root of both sides of the equation. So I have x plus b over 2a. Quantity squared, the square root of that is equal to plus or minus the square root of b squared minus 4ac all over 4a squared. So taking the square root of the square, that cancels. So we're left with, on the left-hand side, just x plus b over 2a is equal to plus or minus. If we have a square root of a fraction, it's the same thing as the square root of the numerator. So square root of b squared minus 4ac all over the square root of the denominator. So square root of 4a squared. So we're almost done. We want to get x by itself. So we could subtract b over 2a on both sides to get that x by itself. So we would get x is equal to negative b over 2a plus or minus. I cannot simplify the numerator in the second fraction, so I'm going to write it as the square root of b squared minus 4ac all over. I can take the square root, though, of 4a squared. The square root of 4 is 2, and the square root of a squared is a. So now notice that I have a common denominator in here. And so I get x is equal to negative b plus or minus the square root of 4a, square root of b squared minus 4ac all over 2a. So with that process of completing the square on a general form of a quadratic equation, notice that you just got your quadratic formula. Let me just write that down now. So the quadratic formula is another method that you can use to solve quadratics. So if you have the form ax squared plus bx plus c equals 0, it has to be quadratic, so a can't be 0. If it was, it wouldn't be quadratic. You could solve for x. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So technically, you would just need to be able to identify what your coefficient a is, your coefficient b is, what your constant is, and then plug it into that formula. But like I said, you need to know how to complete the square, and that's something that we'll be doing over and over in this class. So let's look at some examples that actually have numbers in there. So looking at the following example, we have 2x squared minus 3x minus 1 equals 0. And we want to use the completing the square method to help us solve this. So the first step says we want to make that coefficient, that number in front of the x squared, to be a 1. And so I don't want the 2 in front of the x squared, so I can go through by dividing every single term by that number, which is the same thing as saying I'm multiplying everything on the left-hand side by 1/2 and everything on the right-hand side by 1/2. So doing that, I just created a 1 in front of the x squared, which I wanted. So I have x squared minus 3/2 x minus 1/2 equals 0. So once you've gotten that coefficient in front of the x squared 1, we want to move the constant to the other side of the equal sign. So that's telling me I want to add 1/2 to both sides. So I have x squared minus 3/2 x. I'm going to leave a space here so that I can add the number that would make it a perfect square, is equal to 1/2. So we've moved the constant on the other side. It's now telling us to find the value of 1/2. So I'm going to do it on the side. Times my b value. B over a in my original, which is this negative 3/2. And then we're going to square this result. So if I simplify this before I square it, I would have negative 3 all over 2 times 2 is 4. So negative 3/4 squared. So negative 3 times negative 3 is 9. 4 times 4 is 16. So the number that I want to add on both sides of the equation is this 9/16 plus 9/16. So what we've just done was we manipulated it so that we could rewrite this one side as a perfect square. So it's going to be x, and then whatever we took before we squared it. So it was negative 3/4 before we squared it. So I'm going to put minus 3/4 in here. Which, if you added negative 3/4 plus negative 3/4, that's negative 6/4, which reduces to negative 3/2, which we wanted. And negative 3/4 times negative 3/4 multiplies to 9/16, which we wanted. This is equal to, I notice I can combine those fractions once I get a common denominator. My common denominator is 16. I have that for one of my fractions, so I need to multiply the 1/2 by 8 over 8 to get a 16 in that denominator. So that would give me 8 plus 9 all over 16 on the right-hand side. So we can use the square root method now. So taking the square root of both sides. We have the square root of x minus 3/4 quantity squared is equal to plus or minus the square root of, well, 8 plus 9 is 17 all over 16. So square root of the square leaves us with x minus 3/4 on the left is equal to plus or minus the square root of 17 doesn't reduce, all over the square root of 16, which reduces to 4. So we're using that square root method to solve. So we're now just isolating our x. We can isolate our x by adding 3/4 to both sides. When I add 3/4 to both sides of the equation, I have a common denominator, so I can rewrite that as a single fraction. So x here is equal to 3 plus or minus the square root of 17 all over 4. So there's an example of using the completing the square method. So next example is 3x squared plus x minus 1/2 equals 0. We want to solve this by completing the square. And so looking at this, I want to divide everything through by 3. I noticed that if I divide everything through by 3, I would have a complex fraction in there. And so instead of dividing everything through by 3, another way we can think of it is multiplying everything through by 1/3. Whatever we do to one side, we got to do to the other. And so if I distributed 1/3 to the 3x squared, I would be left with just x squared. If I distribute the 1/3 times x, nothing cancels, so it's plus 1/3 x. Distributing the 1/3 times negative 1/2, that gives us minus 1 over 6 is equal to 0 times 1/3 is 0. So the coefficient in front of the x squared is 1. We want to get the constant to the other side of the equal sign, so we can add 1/6 to both sides of the equal. So we have x squared plus 1/3 x. I'm going to leave a little space here, so plus is equal to adding 1/6 to both sides, 1/6. So and I want to figure out what value I can add to itself to get 1/3, and that number that if I square what I add to itself to get 1/3 would be what I want. So I'm having 1/3. I want half of that value, and I want to square it. So that would give me 1/6 quantity squared, which is 1 over 36. So I want to add 1 over 36 to both sides of my equation. So we just manipulated it so this left-hand side is a perfect square. So the same number that you would add to get 1/3 and multiply to get 1 over 36 is the number before we square it, which is 1/6. So we have x plus 1/6 quantity squared is equal to, well, before I can sum 1/6 and 1 over 36, I need a common denominator. So my common denominator between 6 and 36 is 36. So in order to get 36 in the denominator for 1/6, I need to multiply it by that fancy one of 6 over 6. Doing that, I get 6 over 36 plus 1 over 36. So now taking the square root of both sides of our equation, we got the square root of x plus 1/6 quantity squared is equal to plus or minus the square root of, let's just sum these together and put it under the radical. So 7 over 36. Taking the square root of the perfect square, I get x plus 1/6 is equal to plus or minus the square root of 7 divided by the square root of 36, but the square root of 36 is just 6. Get x by itself, we could subtract 1/6 on both sides of our equation. So I get x is equal to negative 1/6 plus or minus root 7 over 6. So x is equal to, I can combine this as a single fraction. We have a common denominator of 6. So x is equal to negative 1 plus or minus root 7, all divided by 6. So I'm okay with you leaving it like that, but that is two separate solutions, negative 1 plus root 7, that quantity over 6, and negative 1 minus root 7, that quantity all over 6. So the other method is the quadratic formula. Before we look at the quadratic formula, but we did derive it and we did write it down, let's look at the rules for discriminant. So in front of us, we have consider the quadratic equation ax squared plus bx plus c equals 0. A can't be 0. The solution to an equation can be found by using the quadratic formula, which is x is equal to negative b plus or minus the square root of b squared minus 4ac. And this is all over 2a. We say what's underneath the radical, that b squared minus 4ac. This is called the discriminant, and the discriminant will tell us how many solutions we have when we solve, and it will tell us what type of solutions we have. It won't tell us what the solution is. But if we're only looking for real numbers as our solutions, then this could be helpful. So if we want to look at how many solutions we have and what type of solutions we have, we're looking at what's underneath the radical, b squared minus 4ac, which again is called the discriminant. If b squared minus 4ac is bigger than 0, then we can say that there are two unequal real solutions. Which makes sense because what you have underneath the radical is a positive number. And so we'd have negative plus or minus the square root of that positive number. But if we have b squared minus 4ac, if this equals 0, then we only have one solution. And they are telling you that it's a double root, which I've never heard that before. But basically, what we had talked about before, the multiplicity is going to be 2. So there's one solution, one real solution. Again, that kind of makes sense. If you're taking the square root of 0, the square root of 0 is 0. So up here in our formula, you'd have negative b plus or minus 0. Well, that's just negative b. So you'd have the solution of negative b over 2a. If what was underneath the radical, b squared minus 4ac, is less than 0, then there is no real solution. So the next section we're going to look at are complex numbers, and that's negative numbers underneath a square root, which gives us I. And so right now in this section, we're not looking at complex numbers as being part of our solution set. And so we would just say there's no real solution. So let's just look at one example using the quadratic formula. And before we use the formula, let's look at and see how many solutions that we're going to get by using the discriminant. Okay, so looking in front of us, we now have an example, 4x squared minus 2x plus 1 equals 0. Let's first look at how many solutions we have and what type. And so I want to look at what is b squared minus 4 times a times c. So b is the coefficient in front of just the x, which is -2. So we have -2 squared minus 4. A in our case, that's the number in front of the x squared, is 4, times c, and c in our case is the constant, which is 1. So -2 quantity squared is 4. 4 minus 16. So 4 minus 16, this is equal to -12. So the result of our discriminant, this is a number that is less than 0. And so I know that this here has no real solutions. So if it wanted us to just find the real solutions, we could stop. If we want to use the quadratic formula, just so that we can get used to that, let's just do that really quick, and it will be a start for the next lecture, which is on complex numbers. Okay, so if I was to use the quadratic formula, it's x is equal to -b, so negative of -2, plus or minus the square root of b squared minus 4ac. Well, we already did that work over there, so let's just put what that result was, a -12, all over 2 times a, and a is 4. So let's simplify this down. We have x is equal to negative of negative is positive, so +2 plus or minus the square root of, I can break this down as 4 times -3, all over 8. So I have x is equal to 2 plus or minus, I can break down the square root of a multiple as the square root of the first. Square root of 4 is 2, times the square root of the second, square root of -3, all over 8. Notice in the numerator, I have a 2 plus or minus 2 -√3. So I can actually factor out a 2 there. So if I pull a 2 out of a 2, I'm left with 1. Plus or minus, if I pull out a 2 from 2 square root of -3, I'm just left with a square root of -3, all over 8. So I did that so that I can now simplify. I see I have 2 in the common in the numerator denominator. 2 goes into itself once, and 2 goes into 8 4 times. We'll see that the square root of -1 is I. And so we can rewrite this as x is equal to 1 plus or minus square root of -1 is I. So I root 3 all over 4. So after the next section, we will be getting answers that could be imaginary, like this is. So that is the different methods of solving quadratic equations.